Okay. Are you able to see the screen?
Yes.
Wonderful. We begin. So for question, we ended on question 10 last time we met. So continue from question, we ended on question 9. So continue from question 10 until, yeah, the last part. So question 10 was requiring us, question 10 was requiring us to expand this guy here, right? So we have been given to expand expand using like they didn't specify the expansion to you. So here you can even use the what's this the Pascal's triangle, isn't it? So here we use the binomial theorem to expand this. So now when you're expanding this using this binomial theorem, so you have this theorem here which says that a plus x to the power n should be equals to a to the power n plus the n there. I think you have seen this formula in your notes or in John Bed this there. So now when you have been told to expand this thing here, what you do is you just have to know that your a is always 2, right? So we are comparing this to that, right? So you know that a is 2, right? And then our x, which is here, it's x there, right? Then our n is 5, isn't it? So now when you have this data here, we know that the expansion will end up to n to the power 5, right? So you just write it down the way it is, up to 5 here. Then you start plugging in now in this expansion here. So your job here is yeah. So when you are just substituting here in the following expansion using the binomial theorem, you know that our a it's 2, isn't it? And then we say 2 to our n it's what? It's 5, right? So 2 to the power 5 plus here our n is what? It's 5, right? Then our a it's 2, isn't it? Here we have a 2, right? To the power 4. So here it's reducing, isn't it? Then what's our x? Our x is simply x, right? Then we come here to the next step now where our n it's 5, and then it's 5 minus 1, which gives us 4, isn't it? Then here our a it's 2, isn't it? But our n it's 5, so 5 minus 2, we're getting this 3 here. Then we go to the next one, our x here it's simply x, isn't it? So we plug in x, we get x squared plus we have 5 here, right? And then our n it's 5, so 5 minus 1, we're getting this 4 here. Then here we have 5 minus 2, we're getting this 3 here. And then we have something like our a here, it's 2, isn't it? So 2, then the n there, the one on top there, it's 5. 5 minus 3 is the 2, which is there, isn't it? And then our x is simply x. So when you do the substitution for everything, you discover that 2 to the power 5, you get it, it's 2. And 5, and then this is 2 to the power 4. Now, what is 2 to the power 4? You know that 2 to the power 4 is 16, isn't it? So 16 times 5, we're getting this 80x there, right? Then here we have 5 times 4 times 2 to the power 3, right? So what you do there is simply, we can even say 2 into 4, you have 2, right? So 5 times 2, it's 10, isn't it? And then 2 to the power 3, it's 8. 8 times 10, we are getting this 80x squared there, isn't it? Then we come here again. You know that the 3 there can cancel that one. Then the 2 can go in there. So you have 10 there, isn't it? So 10 times this 2 to the power 2, it's 4, isn't it? So 10 times 4, it's 40, right? So you have 40x to the power 3 plus, when you come here, we know that the 4 we can cancel there, right? Then the 3 can cancel, and the 2 also can cancel there. So you remain with 5 and 2, isn't it? Now 5 times 2, it's simply 10, which is 10x4 to the power 4 there. Then you do the same here. The 5 is common, isn't it? So you can cancel this and that. You remain with x to the power 5. Are we clear on how to expand this function? Question 10. Any questions? Hello, is it clear for question 10? We proceed. Hello, is everyone clear? Sorry, it seems I lost the network there. Is everyone clear on question 10? Okay.
No, sir. Kindly repeat.
Okay. What I was saying is that when we have been taught to expand this, isn't it? We're just expanding this part because we have not started to solve A and B, isn't it? So what you do for this part here, you just use this formula here, isn't it? So when you have this formula, remember that this formula, you shouldn't forget it. Huh? It will be very useful in the exam. So when you remember that A plus X to the power N, this is the right way to write it, isn't it? This is the standard. So you have to master this thing, or you just have to know about how it goes. Huh? So I don't know how you put it in your head, whether by knowing it or you master it, but what is important is that you must know it, this formula by heart, because it's very useful. So when you know this formula, you just start comparing with this guy you have on top here. So you know that 2 is also comparing with the A, isn't it? So you know that A is equals to 2. Then X here is the same as the X which is there. So you have X is equals to X. Then the N is the same as the 5, isn't it? So N is equals to 5. Then you just substitute in this formula that you have here. So when you substitute now, you just start doing a little bit of manipulations, whereby you play around with this thing here. So you have, when you do the substitution here for instance, A to the power N, we know that A it's 2, right? And then N it's 5 here. When you do the 2 to the power 5 there, you do those simple calculations, you find that you have 32 plus 80x plus 8x squared plus 40x to the power 3 plus 10x to the power 4 plus x to the power 5, right? So now when you just play around with these ones which need to be cancelled, you find that you have something like this as your final solution. Now when you reach here, your next goal is, the question is, use the expansion, the one you have expanded, to find A, which is 2.1 to the power 5, isn't it? And we have this other one, which is 1.9 to the power 5. So when you notice here, I took this one, the 1.9 to the power 5. For the 2 one, you do it on your own as your exercise. Yeah, so we have 1.9. Well, now 1.9 can be written in form of 2 minus 0.1 to the power 5, isn't it? Then now when you come to comparing, you have 2 minus 0.1 to the power 5 with 2 plus x to the power 5. That simply tells you that our 2 is equals to 2. So we have the 2 there, which is equivalent to that 2 there. Then you have x, which is here, is equals to negative 0.1, which is there, right? Then our n is equals to 5. So n is 5 and both there is 5. So now since you know that x here is negative 0.1, isn't it? We'll just substitute, right? We'll just substitute in our original function here. Where there's x, we put negative 0.1, isn't it? So you put negative 0.1 there, you plug in negative 0.1, and you also do the same here, isn't it? So now when you reach at this point, if you are failing to multiply these guys the way they're supposed to be, please don't give the wrong answer here, isn't it? So if you're failing or you're having challenges in terms of multiplying, it's better just leave it the way it is if you have failed to multiply, rather than giving something wrong here. So you know that 80 times negative 0.1, if you can do that, I believe you can, using your own head, isn't it? To give you something like negative Why this guy not clear? So we have something like -8, isn't it? So -8 plus, when you multiply 8 times the square root of -0.1, it's give you probably a positive 0 point something there, isn't it? Then when you multiply it with the 8, it's giving us 0.8, right? So you do the same for every step which is here. You find that you have something like whereby you have 32 minus 8 plus 0.8 minus 0.04 plus 0.01. Then you do the subtraction. You're having 24.760999. Is it okay?
Sir, kindly repeat, please.
Okay, on which part? On the expansion or this part where we're substituting?
The part where we're substituting.
Okay. So here, okay, so as I was saying, we've been given to find, use the expansion to find, there's A 2.1. I believe you can do the manipulation for this one. Then you have B 1.9 to the power 5. Now, when you have 1.9 to the power 5, you know that 1.9 to the power 5 can be written as 2 minus 0.1, isn't it? Because when you subtract 2 minus 0.1, you're getting 1.9 there. Now, when you write it in this form, you can now compare it with the one here, the one you have from the expanding. We have expanded this guy here. So I've noticed that there's a 2 there, isn't it? Now, here there's a plus x here, isn't it? But here we have negative 0.1. So we're able to see that the 2 which is here is the same as the one which is there, right? Then these guys are equal. Then x, which is there, right, is equals to the negative 0.1, the x which is there is equals to negative 0.1, which is there. So these are equal, isn't it? Then the n now, the n is equals to 5. So n there it's 5, and also there is 5. So they are equal, isn't it? So now where there's x, instead of us leaving it the way it is, that x there, isn't it? We plug in negative 0.1. When you plug in negative 0.1, there's where there's x here. It's like we're finding now we're finding the value, isn't it, of this expansion at x, when x is equals to negative 0.1, the one we have found, isn't it? So when you plug in here, we find that you just now do the simple multiplication, right? So you have 8 where there's x, you are putting negative 0.1, which is there, right? So negative 0.1 times 8, we're getting negative 8, should be, isn't it? Then plus 8 times this guy here. It's just that you guys are not allowed to use calculators in the exam. Yeah, so I don't know how they'll bring small values, I believe, which you'll be able to calculate using your own head, isn't it? So when you simplify this guy, when it comes twice, you should have something like 0 point something something, right? Now that 0 point something something, you multiply it with 8, you get 0.8, isn't it? Then here we have this to the power 3, isn't it? So it should give you something like negative 0.001. Then when you multiply that guy times 40, you are getting negative 0.04. So you do the same for everything. Here to be positive. So here we have positive 0.001 when you multiply this guy and that. Then here, since it's 5, it's negative 0.0001. So when you multiply the negative 0.1 to the power 5, you're having this guy here. We have 1, 2, 3, 4, 5 zeros, and then like a point there. So now when you do this, you just say 32 minus 8, you get your answer. Then you have the same answer plus 0.8. When you do all this addition and subtraction, you find that this will be your final answer here. As for your expansion, that's how you tackle question 10. Is it now clear, please? Hello?
Yes, So it's clear.
All right, we
It's
proceed.
clear now.
So we go to question 11. Question 11, we have been given that expand each of the following expression in ascending powers of x up to and including the terms x to the power 3. So we're trying to expand this guy up to the terms including the up to x to the power 3 in short, in ascending. So ascending, you know that we start from 1, 2, 3, 4, isn't it? So if they're saying that in ascending powers of x, you know that you have x to the power 0, x to the power 1, x to the power 2, and so on and so forth. So now when you are expanding this guy, you should keep in mind that we have this binomial theorem formula, isn't it, to guide us, right? Always remember to use this guy here on top where we have a plus x to the power n, isn't it? So it's the one we're going to use here as well. So you know that our a here, it's 1, isn't it? Then our n is what? It's 5, right? Then what's our x? Our x in this case is 2x minus x squared. This whole thing here, it will be acting as our x, isn't it? So now when you have managed to identify your x, your n, and 1, then your job is easy. What you do next is simply you just substitute in your formula here, this formula here. You're just substituting, right? So now you know you have to know the formula by heart, I think by now. So using the binomial theorem, you know that our a, since it's 1, we write 1. Now 1 to the power 5 here, it's simply 1, right? So plus here is n, isn't it? So where there's n, we put a 5, isn't it? Then here there's what? There's an x, isn't it? So it will be, it's n times x, right? And then there's a simply there's 1 there. So it's simply, we can just ignore the a for now since it's 1. So now when you have this, when you just substitute here, then where there's there's 5. So it's n minus 1 here. So when you put 5 there, it will be 5 minus 1, which is 4, right? Then where there's x squared, we plug in this guy, we have 2x minus x squared to the power 2, isn't it? Over 2 choose. So here we do the same. We're just substituting. Where there's for the power 3, for the power 3 here, we're just substituting. Where there's n, we put a 5. Then where there's x, we're putting that guy here with the 2x minus x squared. So when you just plug in here all these values, so we're ending up to x to the power 3. Keep in mind of that. So when you reach x to the power 3, you stop, isn't it? Because we're not including terms which are greater than x to the power 3. So here you just put like a plus and the dotted line is there. So now when you are here now, you have this function here. What your next step is simplifying it. So here 1 will be 1, right? So now here we have 5 times 2x is 10x, right? And then 5 times negative x squared, we are getting negative 5x squared, isn't it? Then here we have 2. 2 simply means 2 times 1, isn't it? So 2 into 4, we get 2. 2 times 5, it's 10, isn't it? So it is 10, which is there. Times, when you expand this guy here, we have 4x squared. Then 2 times 4x, 2 times x here, we're having 4x, right? Now 4x times negative x squared, we're having negative 4x to the power 3. Then when you square this guy here at the end, you have positive x to the power 4. So we have expanded this guy here to this, isn't it? Plus, we come to this part here. The 3 there can cancel with that one, right? So this 3 will go. Then the 2 can go into that 4 to have 10, isn't it? So it will be 2 times 5, it's 10, which is there. Then this guy to power 3, I believe you can even use this guy which you have here. So we know that this is when x is the power 2, right? So what if we are multiplying with another one which is here to make it the power 3, isn't it? So we say 2x times 4x, isn't it, times 4x squared. We're having this 8x to the power 3, right? So we multiply again 2x times negative 4x to the power 3. We're having negative 8x to the power 4, right? Then we have 2x times x to the power 4. We're having positive 2x to the power 5 because the powers will be adding, isn't it? So here we have this, isn't it? So now we go to the negative part here. We have negative x squared times 4x to the power 2. We're having minus 4x to the power 4, isn't it? Because this guy is the power 2, then here we have power 2, so the powers will add. So we have negative 4x to the power 4 the negative x squared times positive 4x to the power 3, this negative here to turn into positive. So we have positive 4x to the power 5 because the power is x to the power 3 times x to the power 2, which is there, we're having x to the power 5. Then the last one, we have negative x to the power 2 times positive x to the power 4. So now that when you multiply that one and that one, you have minus negative x to the power 6. Then since we have ended here the multiplication or the expansion of this 2x minus x to the power 3 here, we have expanded it there. Your next job is simply multiply throughout with the 10, isn't it? So here when you say 10 times 4x squared, well, okay, we maintain this part here the way it is. It's there, right? So now here 10 times 4x squared, we're having 40x squared, isn't it? Minus 10 times negative 4x to the power 3, it's negative 40x to the power 3, isn't it? Then 10 times positive x to the power 4, we're having positive 10x to the power 4. We leave it like that. Then we say again, we come to this one, 10 times 8 times 8 times x to the power 10 times 8 to the power x to the power 3, we're having 80x to the power 3. Then we multiply 10 times this negative 8 here, we're having negative 80x to the power 4. Then 10 times 2x to the power 5, we're having 20x to the power 5. Then you multiply throughout, you reach at this point. Now, when you reach at this point here, you should keep in mind that we're excluding terms of order x to the power 4 and above. So we don't want those. So negative 10 to the power 6, we will ignore this. We also ignore this 10 to the power x to the power 5. Anything which is greater than 4, isn't it? We ignore even the negative 40x to the power 4, right? So here our final answer will be, here we have 1, the 1 there, isn't it? Plus the 10, which is there, isn't it? Then we get the 5, which is there, we put it there, right? Then the 40x, since we're looking at powers up to 3, isn't it? The 40x to the power 2 there, we put it there. Then we also have, we ignore this part, this 10x to the power 5. And then we also take this 8x to the power 3, right? It's the one which is there. And then the remaining ones are greater than 3, isn't it? So any terms of order x to the power 4 and above, we ignore them. We don't put them in this expansion of ours. So now when you have this expansion, your next job is just to simplify the right terms. So here we have 1, then here the 10x is just the 10x there. Then negative 5x squared plus 40x squared. This will be positive 35x squared. Then negative 40x to the power 3 plus 8x to the power 3, simply 40x to the power 3. Then you're done with this expansion. You even get your full marks. Any questions, please?
The question. So we can proceed.
Hello, you can, if you have any questions, please just text me. Since I'm having challenges with my speakers. Okay, so someone is saying they want to see the general formula once more. So I think the best is try to write it down in your books or a piece of paper right now, because we'll be using this a lot in binomial theorems. So try to take down this formula, try to write it down somewhere. So you'll be just referring to it a lot.
Formula is there in the solutions for tutorial sheet you send. So I think those who want it can get it from there so that we proceed.
Okay. For the questions, or if you're having challenges, please just text me. I can't really get you. Hello. Okay, I believe everyone is okay on this one. We proceed. So that's the final answer. When you just reach that point, it means for question 11, you are done. You even get your full marks. You have expanded it. Is it clear, everyone? You can just text me, please. Okay, we proceed. We got to, for the remaining ones on question 11, use the same concept to finish them. Yes, so we got to question 12. Question 12 is requiring us to expand 1 plus 2x to the power 12 in ascending powers of x up to and including the terms in x to the power 2. And it's requiring us to evaluate the same thing we have expanded on 1.02 to the power 12 connected to two significant figures. Okay. Okay. Mr. Charlie B, can you get me now? You can just text me, please.
Yes, I can get you, but it's not as clear as it was the first time.
All right, wonderful. So for question 12, we've been taught to expand this guy in ascending powers of x, isn't it? And then you know that in ascending just to be increased, isn't it? So now using the binomial theorem, I believe by now you have written it down somewhere, isn't it? So when you're expanding this guy using the binomial theorem, know that your a, it's 1 there, isn't it? Yeah, if Yeah, it's very easy. If you feel as if you can't be going direct like this, isn't it? If you can't handle like the way I've written it down, whereby I've already substituted in the formula, right? So what you do is before you start answering, you can always start by, writing this guy's face, isn't it? Writing this formula the way it is, then you just substitute. I believe we always get the correct answer if you have something to refer to. Hope it's clear though. Yeah, so when you're expanding this guy here, using that formula, you know that our A is 1, isn't it? So we plug in where there's A, we put 1, isn't it? So when A is 1, which means one concentrated, our own focus is on N and X, isn't it? So our N here, it's 12, isn't it? The 12 there, right? Then our X is 2, which is there, isn't it? The 2X, isn't it? So we plug it in our formula, plus here our N is 12, isn't it? Now here there's N minus 1. Now what is N minus 1? You know that N minus 1 is 7, the one I've put there is 7, right? And then here there's a 2 choose. Now 2 choose is simply 2 times 1. Then here we have X, isn't it? Now where there's X, we're putting 2X here, isn't it? So when you plug in 2X there, you'll find that you have 2X to the power 2, isn't it? Plus the 12 there, right? Here we have N minus 1, which is 11, N minus 2, which is 10, the way it is. And then we have 3 choose. Now 3 choose is 3 times 2 times 1. And then here we have X. Now X to the power 3, where there's X, we're plugging in 2X. So it will be 2X to the power 3. Then the moment you do this, then your issues or problems are done. At the moment you just plug in these guys, your next job is just to simplify. So now when you're simplifying these guys here, you find that you have 12 times 2X, it's giving us what? 24X, right? Then here we have 1, isn't it? So 1 plus 24X plus this 2 can go into that guy. We have 6, isn't it? 6 times 11, we have 66, isn't it? Now 66 times 4 here, we're going to have 264 x to the power 2, which is there, isn't it? Because 2x to the power 2 is simply 4x squared. So when you multiply 4x squared times 64, times 66, we're getting 264x to the power 2 plus. Then here we have 12. So the 3 can go into 12 here. We have the 4, isn't it? Then 2 can also go into 4 2 times. So 2 times 11, we're having 22, isn't it? Now, 22 times 10, we're having 220. 220, right? Then 220 times the 8 here, because when you cube root the 2x, we have 8x to the power 3. Then we have 220 times 8, we're having 1760 x to the power 3, plus and so on and so on. So since we're ending up to x to the power 3, we just leave it here. Then you're done for question 12 in terms of expanding in ascending powers of x. Is it Esther? Can you get me now?
Sam.
Okay. Wonderful. I think it's just the network, though it's tripping. So any questions so far? So here we're just substituting and believe everyone is okay. Then the next part is simply telling us the 1.0.2, isn't it? We're trying to evaluate this guy here. Like I said earlier on, we can, play around with this guy here. So now when you play around with this guy, you know that the 1.02 can be written as 1 plus 0.02, isn't it? Then now when it comes to comparing, we're comparing with this guy here. So where there's 1 here, well, 1 is equals to what? 1, right? Then the 2x, which is here, is equals to 0.02, isn't it? So 2x is equals to 0.2. Then the n here is 12, isn't it? So 12 is equals to 12. So there's 12 there, there's also 12 there. So now when you reach here, we can easily solve for x, right? So we can just say 2 divided by this 0.02, you have x is equals to 0.01. So we have x is equals to 0.01. So now when you have x equals to 0.1, your 0.01, your job is easy, isn't it? So we're just substituting while there's x, we're putting 0.01. So now when we substitute here where there's x, we put 0.01. In this function, we have 1 plus 24 times 0.01. Then here we have 264. Where there's x, we put in 0.01 squared plus 1760. Where there's x, we put in 0.01 to the power 3. So now when you manipulate these guys, or when you play around with them, you discover that you have these values down here. So now when you have these values, you can simply add them, or you can just leave them the way they are. If you have failed to expand them, if the values are so big, it's always advisable to leave them the way they are. You can always get your full marks there, but if they're easy, you can easily manipulate them and add them. Is it clear, please?
No, sir.
Any questions?
Sir, I still didn't get on how you were finding the I don't know, they are sending power.
Madam Monica, I have an issue with my speaker. It's like my PC has challenges today, so I can't really get your feedback. Yeah, so I believe just text the question that you are having, then I'll respond. Okay, we proceed. So we go to question 13. Question 13, we've been told that when expanding 1 plus ax raised to the power 10 in ascending powers of x, the series expansion is a plus bx plus c x squared plus 15x to 3. Find the values of a, and then there's a in small letters, then there's a also in capital letters, and b and c. Now, how do we find those values? Then always keep in mind that okay, Mr. Derek, where is the problem, sir? Where are you not clear, please? You can just text me the problem you are facing, then I'll respond. If it's question 12, just say question 12, I'm not clear. I'll get back to it, isn't it? Okay. So for question 12. So here for question 12, since we all agree that this is the expansion, isn't it? For question 12, ending up to x to the power 3, right? So when you know that this is the expansion, we have been given this guy here, 1.02. So we know that 1.02 can be written in form of 1 plus 0.02, isn't it? The power 12. So since we know that this 12, this function here, or this expansion here, we can compare it with this guy here. So you know that we have 1 there, isn't it? And then we have 1 there. So comparing the two, we have 1 is equals to 1. Then here we have 0.02, but there we have 2x, right? So 2x is equals to what? 0.02, right? Then here the 12 and the 12, they are equal. This part we have no problem. Now here, if we know that these guys are equal, we can solve for x. Now, how do we solve for x? You know that when you divide both sides by 2, which means you just mean with x is equal to 0.01. So now when you have this guy here, your job is easy. Just plug it in this guy. Where there's x, you put 0.01, then you do the multiplication from there. So this is what we did here. Where there's x, we plugged in 0.01. Where there's x, we plugged in here as well. We plugged in 0.01. Now, where there's x here, we plugged in 0.01. Then you do the rest from here. I believe you're able to pick it up from here, sir. Madam Messi, which question are you talking about? Question what? Yes, Madam Messi. Madam Messi, for the 4th term, we're not reaching the 4th term. We're ending up to x to the power 3. We're not reaching the 4th term, please. We're ending up to x to the power 3 because we're excluding all 4th terms. You should go through the question. So for question 13 now, question 13, we want to find the values of a. When we are comparing this guy with, there's also another function which is given that a plus bx plus c x squared plus 15x to the power 3. I believe you have the total sheet. You're able to see that one. So now when you expand this using the binomial theorem, you find that the expansion here for a is 1, right? Plus 10. Then here 10 is our n. Then this guy is our x, isn't it? So we plug in what is x, we plug in ax, isn't it? So now, what is 10 times ax is simply 10ax plus, here when we do the manipulation, it's 10 there, right? Now, 10 minus 1, we have this 9 here, isn't it? Now, where there's x, we'll put in ax squared, right? Now, here we have a 2. So, 2 into 10, it's simply 5. 5 times 9, it's 45, which is there. So, we have a squared, x squared, which is 45, ax squared, and x squared there, right? Plus the 3 here, which is we've gone to the 3 factorial, right? 3 factorial can be written as 3 times 2 times 1. So here we have Madam Monica, I can't get you. Just text me, please. So here we have 2, and then here there is 9, right? So I've explained for this one. So this part is 3 into 9. We're having 3 there, right? Then 2 into 10. We're having what? We're having 5, isn't it? Now 5 times 3, it's 15. 15 times 8, we're having the 120 there, isn't it? And then here when we say ax to the power 3, it's the same as we're having 8 to the power 3. X to the power 3, and so on and so forth. We just end here. Now, when it comes to comparing, you get that other equation, this one, I believe you have it in your total sheet. So we are comparing now. Our A is equivalent to what? To the 1 there, isn't it? So A is equals to 1. Then our bx, when we equate it to this guy, we don't have an A, isn't it? So it will be difficult. So it's better we first find our A, which is there, isn't it? So we know that x to the power 3, the coefficient is this guy. Then x to the power 3, the coefficient is 15. So we equate the coefficients, right? So we have 128 to the power 3 is equals to what? Is equals to 15. Then we solve for a. So when the 120 is divided by 15, we're having 1 over 8. Now, the cube root of 1 over 8, it's 1 over 2. It's 1 over 2 there. So now, since we have found our a here, isn't it, to be 1 over 2, we go to our b here, isn't it? So we know that our bx, we're comparing it with what? With 10ax, isn't it? So we take the coefficient to have 10a and the b, right? So we have something like 10a is equals to b, isn't it? So now where there's a, we put a what? We put a 2 here, isn't it? They put a half. So we have 1 over 2. So what is 1 over 2 of 10 is 5. So b is 5. Then we are done with the values of finding the values of a and the cosmolator a and the b. And also now when it comes to c, we know that we're comparing the values, isn't it? So we have the c here is c squared, right? So when you compare it with the coefficient of this guy where there's squared there, it is 45ax squared, right? When you compare the coefficient, you have 45 times 1 over 2 to the power 2 there, isn't it? So now what is 1 over 2 to the power 2? It's 4, isn't it? Now 1 over 4 times 45, we're having 45 over 4 as our c. Then we have solved for all variables of c, b, a, and a small letter a. Is it clear, please? Any questions? Madam Margaret, just text me, please. I'll see your text. I can't really get you. Okay. Oh, sorry about that. It seems power has gone. So the moment you see me going off next time, it simply means that my battery is done. Yeah. Okay. So we've been told for question 10. I believe you have the question. Question 13, sorry. We've been taught to expand this guy in ascending powers of x, and also to find the values of a, b, c, and the cosmolator a, which is there, isn't it? So the first thing that you do when you've been given such an expansion is to use the binomial theorem. So now using the binomial theorem, you realize that we will just substitute here in your theorem. Where there's a, you put a 1, right? Plus where there's n, we put a 10. Then where there's x, you put ax, isn't it? When you do this, you go to the next plus. So here we have plus, isn't it? 10, the n is 10, right? And then here we have 10 minus 1, it's 9, isn't it? Then here where there's x, we're plugging in ax to the power 2. So when you plug in these values, your next job is just simplifying. So here you can use the step by doing this. 2 into 10, it's 5. 5 times 9 is 45. 45 times a squared times x squared, we're having 45 a squared x squared, right? So now here we have 1, here we have 10 ax, the way it is. So here we have 45 ax a squared, sorry, x to the power 2 as well, plus when you do the manipulation here, the 3 can go into 9 3 times, right? So you have 3 there, isn't it? So 3, then 2 into 10 is 5, isn't it? So 3 times 5 is 15. 15 times 8, we're having 120 there. Now here we have 8 to the power 3, ax to the power 3, right? Then when you cube root this 8 to the power 3, you're having 8 to the power 3, x to the power 3. Now when you reach at this point, you start comparing with these things you have here, the one you have been given in your question. So you have a is being compared to 1. So you have a is equals to 1. So you have found the values of a just like that. And then our b, we know that our b here, there's an a here. So there are 2 variables there. So we can't do much with this. So we start with finding this guy, which is around here. The a is around, isn't it? So you have 8 to the power 3. So now when you equate the coefficient of x to the power 3 with the coefficient of this other polynomial, so you have something like 15x to the power 3. So when you equate the coefficient, you have 128 to the power 3 is equals to 15. So the 120, we can divide it both sides. So when you divide by 120 here, we remain with 8 to the power 3. When you do the same, it's 15 into 120, it goes there 8 times, the 8 which is there. So now when you do that, now the cube root, to get rid of 8 to the power 3, we introduce the cube root, right? The cube root of 1 over 8 is 1 over 2. So we'll find the values of this small letter a. Your next job is you compare now the variable x with this variable x which is there. So these variables are the same, isn't it? So which means that we can also equate the coefficient. So we have 10a is equals to b, isn't it? 10a is equals to b. Now, what is our a? Our a will find that it is half, right? So where there's a, we put half. So it is half times 10. We have 5 is equals to b, isn't it? So I'll find the values of b. We go to c, isn't it? Now, c here is x squared, right? And then here we have x squared. So we equate the two coefficients, isn't it? So I have 45a squared with this guy here, the c, isn't it? We equate them. We have c is equals to 45 open, since it's squared, right? 1 over 2 squared. So now what is 1 over 2 squared? It's 4. Well, 1 over 4 times 45, we're having 45 over 4, then you have solved for your c. Is it now clear, please? For the Toro sheet, I'll share it. I believe you guys, you have it. Toro sheet 5. I've sent to all class tips, I think so. I'll try to resend it after this. But is this concept okay for everyone, please? Okay, I think for the what's this, for the Toro sheet, you can find that from your class tips. They have it, please. They'll share it. My phone is too low to send. Yeah, but I'll share it after I'm done with this. So we go now to question 14. Question 14 is requiring us to expand this in ascending powers of x and also find the values of n and a. So now when you notice here, we have a and then here we have n, isn't it? So when we expand this guy, we've been told to find the values of a and n. So here we've been given this second quadratic. This is a quadratic equation in short, the way it looks like. So we have this. So when we expand this guy, we know that we have to end up to x to the power 2, isn't it? Because here we have x to the power 2. So this guy is guiding you to say end up to x to the power 2. So now using the binomial theorem, we'll just, this is the formula, isn't it, for binomial, isn't it? So now here, this is our formula, right? So we're just substituting now where there's a, we're putting 1, isn't it? And then where there's x, we'll be putting a to the power x, isn't it? And then where there's n, we're putting in n again, because here our n is n, right? So we have 1 plus n, open where there's x, we plug in a, x, close, plus n minus 1. Where there's x, we're putting ax to the power 2, isn't it? So we end there. Now, when it comes to comparing, isn't it? We're comparing with this guy on top. Huh? I think it's there in your Toro sheet. So we have where there's x here, isn't it? The coefficient for this guy, it is just x, isn't it? So we compare this guy and that guy here, which has an x around x to the power 1, right? So we have 2, we have n ax is equals to 2x, isn't it? So this x can easily go. So remain with n a is equals to 2. So now when you divide by n, we have a is equals to 2 over n. This will be like your first equation, isn't it? Your first part. Now you compare the second one. This guy, 15 over 8 x squared with this coefficient which is here, n over n open, n minus 1 close. Then we have ax squared over 2, isn't it? So now when you compare this guy here, you have the way it is with the a squared, we ignore the x squared, we don't put it there, we just ignore it, isn't it? So we have a squared there. We compare this guy is equals to 15 over 8. Then we solve for n. Now, how do we solve for n? We know that our a here is 2 over n, isn't it? So where there's a, we plug in 2 over n. Now, the 2 over n is squared, isn't it? So we have 2 over n squared, you're having what? We're having 4 over n. 4 over n squared. So that simply tells you that the 2 here can go and the 4 there can be reduced by 2, isn't it? Because 2 into 4, we're having the 2 there, isn't it? And then this n squared, which is down there, can cancel this one in front. So we have n down there minus this n minus 1 there is equals to 15. So when you are here now, you can just cross multiply. We have this 8 times 2, it's 16, right? 16 times n, we're having 16n. Then 16 times 1, we're having minus 16 there, isn't it? Is equals to 15n. Then you know that the 15, when it comes this side, it will be negative. Then the 16, it will be positive. So it will be 16n minus 15n. We're having n just, isn't it? N is equals to 16. Have you seen that? So when you know that n is equals to 16, your next job is that we plug in this function and we solve for a. So this implies that a is equals to 2 over 16. Now, what is 2 over 16? 2 over 16 is equals to 1 over 8, which is there. Is it clear, please? So this implies that our a is equals to 1 over 8. So we have solved for a and n in our expansion. Is it clear, please? Any questions? Okay, we proceed to the next one. And you guys, you should know that we don't have a lot of time. There are 2 tutorial sheets which are actually pending. We have tutorial sheet 5. Is it tutorial sheet 6 on partial fraction? And then there's another one which has been released currently on trigonometry, isn't it? Yeah, so we will try to speed up some things so that before we close, we should be done with them, isn't it? Yeah. Okay, so for the sake of those, I will try to repeat myself here. We've been told that we expand this guy in ascending powers of x, right? So now, when we're expanding this guy here, we use the binomial theorem here. I've already shown you the binomial theorem, so you just plug in, isn't it? Where there's a, you put a 1, and then where there's x, you put ax. Then where there's n, we're just putting the same n. So when you plug in that formula I've given you, you have something like this, isn't it? So now when you reach here, your job is done, your expansion is done up to x to the power 2, right? Your expansion is done. Your next job is just comparing. 1 here is equals to the 1 there, right? Then the 2x here, you can be compared with this n. Okay. All right, we proceed. So now here, when we are using this formula, right? When we just plug in, our job is the next part is just comparing what coefficient does this x to the power 1 has as we compare it with this other one, this other function here. So here we can just say that 2ax is equals to 2x, isn't it? Because these are having the same x, isn't it? So here there's x to the power 1, then here there's x to the power 1. So we are comparing this coefficient which have x to the power 1 in them. So here we have 2a is equals to 2. So now how do we solve for a? We can just divide by n. We have a is equals to 2 over n. So now when we do that, we go to the next part, we compare here. We compare here now, we have 15 over 8x squared, right? And then here we have a x squared, isn't it? So now when we compare the x squared, the coefficient, you discover that we have n minus 1, then a squared, right, over 2 is equals to 15 over 8. We're comparing the coefficients here, isn't it? So when you do that, you just play around with this guy. Where this a, we're substituting 2 over n squared, isn't it? So now when you do this guy, it will give you, when you square this guy, to give you 4 over n squared. Now, n squared times this n which is outside, they can easily cancel, so remain with n down here. And then this 2 can divide with this 4 which is up here. So you have something like 2 times this guy here, it will be 2 times n minus 1 over the n which remain there. When you do the manipulations, is equals to 15 over 8. Now, when you cross multiply, we have 16n minus 16 is equals to 15n. When this you solve for n, you discover that this 15 here, it comes inside to be 16n minus 15n. We're having n just, isn't it? Then the positive 16, when it comes inside to be n is equals to positive 16. So since we know that n is equals to positive 16, we can find the exact value of a. So we plug in where there is n, we plug in 16, and then we simplify this to is equals to 1 over 8. Hope it's clear now. We proceed. Question 15. Question 15, we've been told to find the term involving x to the power 8 in our expansion. So here, this is the question, right? So we've been told to question 15. We've been told to find the term involving x to the power 8 in the expansion of this guy here. Now, how do we do that? So we're trying to find the term involving x to the power 8, isn't it? So I believe by now we have seen the general formula, right? How it looks like. So here, using the general formula is simply this guy here, where we have n over r, n choose r, and then x here we have multiplied by x, n minus r, y to the power r there, isn't it? So this is the general formula here, isn't it? So now we know that this n of then n choose r can be written as n choose, isn't it, over n minus r, we close. When we put a choose here, isn't it? Then we put a r there, factorial, isn't it? So this is the general formula. I think we'll be using it in this function, isn't it? So now when you know this part here, we just substitute, isn't it? So where there's n, it's 12, right? Then our r here, we've been taught to find the term involving x to the power 8, right? So you know that our r to be what? It will be 8, isn't it? Because we are considering these values of y here, it's representing our x, isn't it? So when we know that when we put 8 here, we have x to the power 8, isn't it? Then here our x is what? Our x is 4, right? X is equals to 4. Then y is equals to what? Our y is equals to x here. So we just substitute in this general formula of ours. So now when you substitute in this general formula, we have 12 choose 8. And then we open, we do the open close parenthesis. This is 4. While there's n, it's 12, isn't it? And then while there's r, we're putting 8. So it is 4, 12 minus 8, and then x here. Where there's y, we're plugging in x, right? We put it there, right? Now where there's r, we're putting 8. So this is our function here. So now we know that 12 minus 8, we're getting what? We're getting a 2. Huh? We're getting a 4, sorry. 12 minus 8, we're getting a 4 to the power 4 there, isn't it? And then x to the power 8. So now, what is 12 choose 8? So we know that 12 choose 8, according to this formula, can be written like this, right? In this, using this part here, we know that we can have we have 12 choose there, right? And then here, where there's n, we put a 12. 12 where there's r, we're putting what, a 8. So 12 minus r, we're having this 4 here, isn't it? And then our r, it's simply 8, isn't it? So we plug in 8 here. So 8 factorial times the 4 factorial, isn't it? Is equals to, you know that 12 factorial can be written as 12 times 11 times 10 times 9 times 8 factorial, isn't it? We end here where there's 8 factorial. So we compare it to this 8 factorial which is done. So we can just cancel these 8 factorials, right? Then here the 4 factorial can be written as 4 times 3 times 2 times 1, right? So 4 into 12, it's 3, isn't it? And then 3 into 3, it's 1, right? So we only remain with 11 times 10 times 9, isn't it? So when you do those manipulations here, we're going to have 495 times this 4 to the power 4, which is there, x to the power 8. So when you have this 4 to the power 4, you're having 256. So now when you have this, you just multiply these two. So when you multiply these two, we're having this figure here, to the power x to the power 8. So we have managed to answer this question, question 15. Find the term involving x to the power 8. So this is the term which is involving x to the power 8. That's how you go about solving that question. Any questions, please? Okay. We've been told to find the term involving x to the power 8, right? So what you do here is that you use the general formula, isn't it? I believe by now you have seen this guy here. So now using this guy, this general formula here, will be just substituting it. And then you know that n choose r is simply is equals to n factorial over n minus r cross factorial r factorial, right? So we know that this guy is equals to that, right? So now what is our n in this expansion? You know that our n is 12, isn't it? Our r is what? It's 8, right? How do we identify our r? Our r here, we can identify it through this. We have been told to find x to the power 8, isn't it? So it simply tells us that here our y here, the r should be 8, right? So where there's y, when we plug in x here, the power, no matter what it is, should be 8. So it's like it's a guide for our r, right? Now our x is equals to what? Our x is always this part here in this general formula. Our x is this part, our y is that one, then our n is that. So we have x is that, our y is this part here. So when we just plug in where there's y, we put x, where there's x, we put 4. You plug in this general function or formula there, you have 12 choose 8 times 4, 12 minus 8, x to the power 8, isn't it? Because here our y was x, then our r is 8, isn't it? So we're finding the term involving x to the power 8, isn't it? So when you have this, the next job is just to do simple manipulations while you play around with this guy here. So you know that 12 choose 8 is equals to 12 factorial over this is 12 minus 8, which is 4, isn't it? So the 4 which is there, isn't it? So it's 4 factorial. Then the r, it's 8 factorial, right? So now this guy is equals to, the 12 factorial can be written as 12 times 11 times 10 times 9 times 8 factorial. So when you reach 8 factorial, you know that down here we have 8 factorial. So they are common, right? So they can easily cancel these two, right? Then the 4 factorial can be written as 4 times 3 times 2, isn't it? So when you just do this, you know that 4 into 12, it's 3, isn't it? Now 3 into 3, it's 1, isn't it? So you have 11 there. Now here there's a 2, right? So 2 into 10, it's 5, isn't it? So now 5 times 11, we're having 55. 55 times the 9 here, we're having this value here, 495 times the 4, we take this 4 which is there, 12 minus 8 is to the power 4, right? So we have 4 to the power 4, the x to the power 8, the way it is. So now the 4 to the power 4 is 256. 256 times that guy will have been 126,720 x to the power 8. So this simply means that our 80th term, it's 126,720. It means we have solved our question here. We even get our full marks. Is it now clear, please? Okay. Wonderful. We proceed. So for question 15, this is 16, sorry. Find the coefficient of x to the power 3 in the expansion of A, 5 plus 3x to the power 8. I believe you are able to see this question, isn't it? So now we're finding the coefficient of x to the power 3. So this should always give you the idea that our expansion will be ending at what? X to the power 3 if we're expanding it. But there's a shortcut way of finding this thing here. We can easily use the general formula. So now, using the general formula, we know that when you have 5 plus 3x to the power 8, we know that using this formula here, what would be our n? Our n here, it's what? It's 8, right? And then our r here, well, they have told us to say we have to end up to x to the power 3. So here our r has been guided to say our r is what? It's 3, isn't it? R is equals to 3, right? Then our x there in our formula, it's 5. Then our y here is 3x, isn't it? So when you have this part, we just substitute in this general formula, isn't it? So we have our n, it's 8. Our r is 3. Then our x is what? It's 5, isn't it? Then our n again, it's 8, right? Minus our r is 3, isn't it? What is y here? We're plugging in 3x to the power 3, isn't it? So when you have this, when you cube root this thing here, when you just say 3x to the power 3, it's 27x to the power 3. So when you have this part here, we know that 5, 8 minus 3, it's 5, isn't it? So you have 5 to the power 5, right? Then 8 choose 3 can be written as this, isn't it? So we have 8 choose 3 over 5 factorial times 3 factorial, right? Is equals to, so here we know that 8 factorials can be written as 8 times 7 times 6 times 5 factorial. So the 5 factorial and the 5 which is here can cancel, isn't it? Now the 3 factorial is the same as 3 times 2, isn't it? Now 3 times 2 is 6, isn't it? So 6 then the 6 on top can cancel, right? Then 8 times 7, we have 56 here. So here, since we have known that 8 choose 3 is 56, so we say 56 times 5 to the power 5 times 27x to the power 3, isn't it? So when you multiply this guy, you're having that the coefficient of x to the power 3 is 56, 5 to the power 5 squared times 27. So when the figures here are too big, you can just leave it the way it is. But if you're able to multiply, you can say 5 to the power 5, it's 3,125 times 56 times 27. You having this guy to be our coefficient. That will be our final answer. Any questions, please, on how to find the coefficient? Is it clear, please?
Could you repeat that one again?
Okay. Yeah, and please, for the figures, don't mind them. Like I said earlier on, if the figure is too big, like the way it is here, if you're able to manipulate this guy, you can even leave it here the way it is there, isn't it? We're able to know because we know that you're not using the calculators, right? So they're able to tell that these figures are hard to multiply. These figures are to multiply. So we've been told to find x to the power. We've been told to find the coefficient. This is question 16. Find the coefficient of x to the power 3 in the expansion of this, isn't it? So when you're finding the coefficient of x to the power 3, what you do is that you use this general formula, and then when you have this general formula, you just substitute. What is r? R is equal to what? It's 3, isn't it? Because we're ending up to x to the power 3, right? The coefficient of x to the power 3. Our n is what? Our n is h there, right? Our x here is equals to 5. Then our y is equals to 3x, isn't it? So now, when we just substitute this guy in our general formula here, we have h to 3 times 5, 8 minus 3, 3x to the power 3, right? Now, what is h to 3? We know that h to 3 is simply the 56 here. When you do the manipulations there, you play around with this guy. So you have 56, then 5, 8 minus 3, it's 5, right? So it's 5 to the power 5. Then here we have 3 to the power 3, it's 27. X to the power 3, it's x to the power 3, isn't it? So now here we are ignoring this x to the power 3 because we're just interested in the coefficient. Then know that the coefficient is this guy here, the 56 times 5 to the power 5 and times 27 there. So this is our coefficient, right? So like I said earlier, if you're able to multiply them, or you can multiply them, just multiply them so that you simplify everything. But if the figures are too big, you can leave it the way it is here, the way it is done here. But if you're able to multiply them, you reach here, it's also well and good. Yeah, that's what I was saying. Hope it's clear now. Yeah. Should we end here for today, please? Probably we can do some other time, or we'll arrange for another makeup.
Aningasi poenda kunichina kwa ndefu. Mse kuchina kuburu.
Hello, should we continue, or maybe we end here for today?
Please just post a video, sir.
Sir, you can continue.
So our batteries are down. If you continue, some of us, our phones will go, we won't have power.
All right, I think we'll end here for today. We'll arrange for another meeting next time. So please just go through these remaining questions so that it is easy for you to digest them. So next time we'll meet to start from question 17. Huh?
Yes, sir.
All right, you guys.
Yes,
have a blessed day.
Thank you, sir.
Oh. Post the video, sir.